Alrighty, so we need to figure out the difference between simple interest and compound interest. Let's go. So simple interest is the interest is equal to the principal amount times the rate. The rate needs to be a decimal. So we got interest, principal, rate as a decimal, and time. Every now and then in this formula, that T may be a Y, which represents years. But in general, we'll say the interest is equal to the principal times the rate times the time. So let's say you're going into a car dealership and you're looking to buy a loan. You've made the deal, and you're looking to buy a car. You've made the deal, and now you need to go apply for financing and all that stuff. And so, you get all that figured out, and then you go into the finance department. And so the finance department guy, he's talking real fast, all these terms. It's like, whoa. But in those terms, what he's going to say is this is a simple interest loan. If you don't get a simple interest loan, then you may need to go somewhere else. just so you know. So car loans are simple interest loans, which means you're going to borrow the money to purchase this vehicle from a bank or a credit union or wherever. That bank is going to purchase that car, but they're going to charge you interest. And so they'll give you a rate, and then they'll give you a term. 60 months, 72 months, 84 months, so on. Those months, such as 60 represents 5 years, right? 72 months represents 6 years. 84 months, that's a long car loan. That's 7 years. Nowadays, there is a 96-month option. I do not recommend taking out a 96-month loan for a car, but that is available. And they go through all these terms, all the loan term, all these the length of these loans to try to lesser your payment. But you do need to be careful. That's a story for another day. This video is meant for the simple interest. And so what's going to happen is they're going to say, okay, you're going to borrow. Let's say we borrow $25,000. Let's say rate nowadays is roughly around, depending on your credit, roughly around 5-6%, I believe. I haven't purchased a vehicle in a few years, so I'm not quite sure what the going rates are right now, but let's assume we have a 5% rate. Now, what we want to do with that 5% is convert it to a decimal. If you're going from a percent to a decimal, you're going to move that decimal place 2 units to the left. Or you can just say, okay, percent, per in math means to divide, and then think about cent, right? Cent, there's 100 cents in a dollar, so percent divide by 100. So if you divide 5 by 100, you get. We need to use this in our calculations. Keep that in mind. You want to use the decimal representation of your rate, okay? And then years or time, let's say our term was 72 months, which is 6 years. So we're going to use 6 years in our calculations. Okay, so what we're going to do is take 25,000. So the interest that I'm going to be charged to take out this loan is going to be calculated by taking the principal, 25,000, multiply that by the rate, which is 0.05, multiply that by the term, which in this case we said was 6 years. That's going to be the total interest that I'm going to pay for this particular car. All right, so let's go over to our calculator. All right, and let's type in 25,000. Let's see if my keyboard doesn't type it in. So I have to do it with my mouse. 25,000 times 0.05 times 6. Wow. So the amount of interest that we're going to be charged is $7,500. Okay, $7,500 in interest. So just to take out this loan to buy this car, our interest is going to be $7,500. All right, that's the simple interest. And so, we can add on to this question. We could say, okay, well, if I'm paying $7,500 in interest on top of $25,000 for the vehicle, how much is my monthly payment going to be? Well, the total or accumulated, whenever you see that capital A, think accumulated. The total of money that you're going to pay back is going to be the principal plus the interest. And so let's just jot this down. I just wanted to make sure I had the colors right. So that would be the total paid back, right? Total paid. Let's write it like that. So if I go to a car lot and I want to buy a $25,000 car, and we're just talking car loan, we're not talking taxes, tags, all that stuff. If my loan amounts for $25,000, my terms are 5% for 6 years, then I'm going to pay $7,500 in interest just to take out that loan to purchase that car. And so the total that I'll have to pay back, the $25,000 for the car plus the $7,500 fees to take the loan, I'm going to pay a total of $32,500 for that car over 6 years. So what will my payment be? Well, my payment will be the $32,500 divided by the number of payments, which in the term that we chose for this particular problem with 72 months. So divided by 72 months, and that would be, let's go ahead and add this 25,000 divided by 72 months. So our payment will be roughly $451.39. Okay, so that's simple interest. Okay, it's calculated. It's called simple interest because it's basically calculated by taking the principal times the rate times the term or the years. All right, so now let's talk about compound interest. Now, compound interest has a much different formula. Compound interest has this formula. We've seen all these letters, but we'll still discuss them. The A, which is going to represent the accumulated amount, is equal to the P, which is the principal amount, times 1 plus the rate divided by N. N we haven't seen yet. N is going to represent the number of compounds. We're going to raise that quantity, the 1 plus R over N, to the N times T power. Now that's where a lot of issues get made, the N times T power. So we do have to be very careful with our algebra. Okay? So let's say accumulated value, or the value total, right? Accumulated is the accumulated over that term, the number of, in this case, years. I'm going to use years for this example. We know P represents the principal, R is the rate as a decimal. N is going to represent number of compounds. don't know why that stray red mark is there. So number of compounds. In this case, we're going to say number of compounds over a year. So let's look at a similar example. Let's say we borrowed $25,000. Now, car loans are not compound interest car loans. If you're going to take out a compound interest car loan, then you may want to shop around. Car loans are typically simple interest, so keep that in mind. But for the sake of comparing the two, I want to use the same values, but then I want to say, okay, we're going to compound a $25,000 loan annually or semi-annually. And we're going to see the difference between simple interest and compound interest. The rate, we're going to say the rate again is 5%. The time, the years, is going to be 6 years, just like before. But this time, let's say we're going to compound it annually, or sometimes you may see the word yearly. So that means every year we're going to compound it one time. If you see compounded annually or compounded yearly, that means compounded once each year. So let's say n is equal to 1. All right, we'll set this up. We'll say, okay, well, the accumulated value is equal to 25,000 times 1 plus 0.05 over 1 times, to the power of 1 times 6. So that's everything set up. Now, whenever your n is a 1, we know anything divided by 1 is itself. Anything times 1 is itself. So I can go ahead and simplify the way this is written a little bit. I could say, okay, well, 0.05 divided by 1 is 0.05. Six times 1 is 6. Okay, now using my order of operations, PEMDAS, remember you want to, let's write down PEMDAS. Using PEMDAS, you have to take care of parentheses first. So inside my parentheses, I have 1 plus 0.05. So let's go ahead and take care of that. Now, I have a simple number in my parentheses, so there's no operations inside my parentheses, so I'll move on to the E in PEMDAS, which is exponent. So now I want to take that 1.05, raise it to the 6th power. Now, what you really need to be careful of in these problems, you never want to round in the middle of a problem. So this is probably going to be a decimal that is going to continue for quite a while. So let's look. We have 1.05. We're going to raise that to the 6th power. There's our decimal. Now we do not want to round that. We don't want to round it at all. So what we want to do here, let's go back to the other screen. And let's say, okay, well, 1.05 to the 6th power is what we just saw in the calculator. We're going to multiply that by 25,000. So go ahead and take that exact value there, the 1.340095641. There's probably some numbers that actually continue on after that 1 that we see on the calculator. Go ahead and multiply that, just say times 25,000. And we get $33,502.39. So the simple interest is a lot less. All right, so see the difference in simple interest and compound interest. Now, let's just build on this a little bit more. Okay, so how about taking the same loan, $25,000, 5%, 6 years, and compounding it quarterly? So let's just have a small review. Simple interest, there was no compounding involved. Compound interest, there is compounding involved. And basically what compounding means is at the end of each year or each compounding period, in this first example, at the end of each compounding period, I'm going to take the interest throughout that first compounding period, put it on top of the loan, and then compound interest on top of that. So I'm paying interest on top of interest, right? So the more times something is compounded, the more interest you're going to pay. All right, and so we're going to see that whenever we calculate this new example. So now what if we take the same amount of money, $25,000 at 5%, 6 years, but compound it quarterly? So that means 4 times a year, this is going to be compounded. So let's set up our formula. Okay, so you really, really want to be careful in calculating this with your order of operations. What I always advise doing is going ahead and taking the 4 times 6 in the exponent, because I've seen a lot of people make mistakes with the with inputting this into the calculator. Go ahead and don't try to input it all at once. Even if you are experienced with that, there's always a chance of making a small mistake inputting something in the calculator, especially when you put in a long calculation. So break it up. Go ahead and say, well, I know 4 times 6 is 24. And then say, well, I know 0.05 divided by 4. If you don't know that, go ahead and go to your calculator. 0.05 divided by 4 is 0.0125. And so now we're here. Go ahead and hit enter. All right, do not round this value, times 25,000. We get 33,000. $683.78. And so now we have a proper comparison. Okay, compounded 1 time a year, we got this amount. Compounded 4 times a year, we got this amount. And so now we can say that compounding more times will lead to, in terms of a loan, will lead to more interest paid. And that's because you're compounded interest on top of interest on top of interest. I hope this video helped. Let me know in the comments if something was helpful, or if you need something cleared up, and I will be glad to help you out. So have a good day. See you in the next one.